All right, hey everyone. Welcome to the CI/CD demos. Today is October 7th. We got about, looks like 8 demos today. So yeah, great lineup. Fred, it looks like you got the first one. Are you ready to kick us off?
Yeah, thanks, Harvey. So this is a work in progress feature that is, it was intended to start as a preview of your YAML configuration for your CI. And so this is someone writes a new pipeline and then they're writing stages for like test or build and all that stuff. Well, we're going to show a live preview of like nodes and dependencies so that they can see what it looks like. For now, it's not a live preview like my previous demo. So like you write it up and then once it's saved, you can go in the tab and see what it looks like. So I'm going to share my screen so we can start taking a look at the cool stuff. Is that the, I think it's the right screen actually. Give me a second, sorry. No, it was the right screen. Okay. Cool. So everyone can see the graph, right? Perfect. So this is what it looks like. I'll show different kinds, a bunch of different configurations. Basically, you have the lines that go through the stage, and usually there's a green border around these little nodes. Currently, my GTK is acting up, so you don't see them. But when you you can see the dependency highlighting also. And the way it works is that if we look at the file, I have a bunch of stages here that I've defined, and then each job has a stage, but some of these stages are not used. And so currently what we do is if you have an empty stage or you're currently working on your stage, you can see like this stage doesn't have anything in it. So it's also a good reflection that you have an unused stage of what you're doing. And if I want to edit and add things in the empty stage, which I can do easily, then we'll see that reflected in the build once we go back. So let's say MTA, it's in the empty stage, and it's just the best script I can think of. And that's it. And here we go. So currently this doesn't have any dependencies, so there is no highlight. Oh, and now the lines are broken. Interesting. Demo, right, everyone? And so I'll just remove, actually I can go in a different project for now. I'm just gonna tag. And so this is what it looks like. In terms of code, a couple of things to note. The first thing is that this page is still in YAML. And so what we did to avoid writing more YAML and then switching to Vue, because this needed to be all in Vue, is that we have a container, which is called the Gitlab CI YAML visualization file. And this basically ties in the YAML tabs with the graph. And so when we change the tab, we get access to the same data that the YAML has. So we have all the CI data, so like your jobs, your needs, all that stuff. And we parse it the same way we did for the DAG graph. And once we have it parsed, then we can feed that to our graph. And there's some extra logic to take care of the fact that the tab is in YAML. And so because the tab is in YAML, if you switch tab, you would usually see, you would still see this, right? Like this is the YAML generating the content of the file. So when we change the tab, we just grab it and remove it from, sorry, we just take whatever this container has and we remove it and replace it with the graph. This is what this component does. And then if we go into the graph itself, then there's a bunch of things that we need to do. And the first thing that is interesting is that we need to figure out how to use the data, the parse data, and then generate, well, first generate the job by stage correctly so we can render it. And then the interesting part starts with the node and the link. And so we have a drawing utility here where this function takes in the data that the API gives us. Well, no, that's not true. We take the data the API gives us and we process it the same way we do with DAG, which is we use D-tree and we generate nodes and links with D-tree, which says, here is your node start points and here is this node start point. And then we have all of the coordinates of our HTML element. And then once we have that, what we can do is we can do some maths and we can say, if I take this stage and I want to go all the way to this stage, which line, what would that line look like? So there are a couple of things we need to do for that to happen. The first is we need to get the coordinates, which is what we're doing here. And once we have the coordinate, this is a couple of just styling adjustment, and it's explained here, which is like, gotta change some padding just so that everything's aligned perfectly. But the interesting part is more how we calculate the source coordinates. So the source being like, let me go back on this. So if we have like, let me just refresh and hope that this fixes it. And if it doesn't, so it doesn't matter. Okay, don't fix it. So let's say that I want to trace the line between build D and test B. Well, I'm going to grab the coordinate of build D, grab the coordinate of test B, and I'm going to get that right, we do some calculation and make sure that we target the center vertically of the nodes and then the extreme right, for if it's a starting node. So if it's a starting node, you can see the node starting on the right. If it's a receiving node, then it starts on like it had reached the left, and it's always in the middle, which is what we're calculating here. And then currently the curves are Bezier. So this we use D3 for. And the way it works is we can pass two things. First is we pass, like if anyone is familiar with Bezier, you have two control points, one near the start and one near the end. And when you're moving them, and if you have a curve, then your control points just make the curve, changes angle. And so we control the Bezier to give the right curve. And for that, we use the control point, which we have calculated above here, which I'm not going to go into the details. But basically, we place these points, we do the curves we want, which is kind of an S-shaped curve. And D3, we can use the Bezier curve too, which is a D3 method. It's also a native canvas method in HTML. So I think they're just re-implementing it. But because right now we're in D3, this allows us to be coherent. Once that's done, then the other interesting thing is how we find the ancestor nodes. Because when I'm highlighting, let's say deploy B, I don't have a quick way of knowing in the data currently, well, what are all of the links and all the nodes that deploy B depends on, right? It's the other way around. Like I can know that I know that test C depends on build D, for example. That's obvious. But if you go further down, you don't know which job this one depends on. So this is a recursive call, which says, I'm going to go and look for this target, and this target, and go all the way and make sure that it has everything, which is a little function that I have here. And so for every needs, we find the needs of that job and we go down. And there are a couple of things we do to make it a bit more performant. The first one is, once we're going down, let's say that I'm starting with deploy B here, and I'm going to test B and then build D. Well, once I reach build D here, and I'm like, okay, well, deploy B needs all of them. I'm gonna add the build D also in not like in a dictionary or an object or a hash. And then because we have it, the next time a dependency goes all the way to build D, we can just grab that one, and we don't have to recursively keep calling. And obviously this doesn't have an impact because it's on the last row, but you can imagine if you're much further down and then you say, oh, I'm dependent on small job and it's dependent on everything else, then we can just say, grab whatever small was dependent on and just put that in. So we save a bunch of, in a small graph like this, with the current dependency, I did the count and it saves about, it was 8 iteration for such a small graph. So on a larger scale, it could probably save a much bigger performance impact. And what else do I have?
This is really cool, Fred. I want to make sure we get time to get to the other demos today too. So I guess I saw Nathan had a question in the doc. Did you want to verbalize that real quick?
Sure. Yeah, I was just curious. Is the visualization live? Like if you edit the file in one tab and switch over to the other one, will it show it, or do you have to actually commit the file to see the update?
It's a very good question. Currently, you have to update the file and save it. It would be pretty easy to have a live visualization as well. As we have shown before, we could just use the editor and live update it. For now, I think the reason why it's not live editable, it's more like a UX problem that will be solved later, where it's like, I need to click edit to be able to change a file. And so from here, I have no change. I just can't, I have to commit my change to come back with my change. So if we had like, if this was live editable from right here, then we could have a live preview as well. This also, for now, will live here, but at some point it will also move to another place, which is another subject. So I don't want to go into that now, but no, it's not live editable for now, is the short answer.
Cool, thanks.
Awesome. Thanks, Fred. Let's see, Jose, I think you're up next.
Yeah, thanks, Darby. Let me just share my screen. List of one, yes. So for the next demo, this is part of the Verify Runner team, but basically it's the install Gitlab Runner pop-up, which basically what the goal for this was to provide the users as an easy way to install runners without necessarily checking documentation, because this is just going to be a button that pop-ups a model inside either project, group, or admin, depending on where you want to install your runners. And it should also support any kind of architecture you want, as well as any platform that we support. So the basic concept for this, say you're in a project, and you go to your settings, CI/CD, and this will live under the runner section, and then you can just click the button, show runner installation instructions, and then you can pretty much copy paste either here or individually any instructions that you want and any architecture that we support for any given platform, including macOS, Windows, Docker. And the nice thing about this is that if you want to download your binaries immediately, you can just do that. I'm not going to download it because otherwise I'm going to drop off of Zoom. And the same thing happens with group runners as well as admin runners. So same thing. And the cool thing about this is that each instructions are basically set for whatever scope you're working. So you don't have to do anything because the tokens are already set for you. Same with runners, like you want to install a runner or like on an admin scope, same thing. You can just copy, same thing, go to your terminal, I don't know, like there. Same, I'm not gonna download it, otherwise this can get bad real quickly. A couple of things. Currently, the first implementation is on Vuex. I'm working towards a solution for GraphQL. A backend help will be greatly appreciated because I'm still mocking some of the data from the front end. And yeah, this short one, but hopefully, if you have any questions, please let me know. Peyton just has a comment. So yeah, this is the end of the demo.
Nice, thanks, Jose. Any other questions? Okay, I think Georgi, you're up next.
Hey everybody. So me and Jose didn't coordinate anything, but basically my functionality is kind of an extension of his. So what we want to do is make it easy to start a runner and deploy it, let's say in GCP or Amazon, and make it like super easy, because one of the first problems people stumble upon when using the runner is how to register it, how to maintain it, and stuff like that. So basically, the thing we want to do is we want to give you 1 or 2 command stops, and after that we're just gonna take over, create instances in GCP and stuff like that. So what we have here is a few Terraform scripts. I'll just show them real quick in a second. And imagine that these instructions are going to live on the same place where Jose's instructions are, you just saw. So we're going to give you some environment variables you need to set. We're going to preview most of them for you. For example, we just need the URL of the GitLab instance. You're going to register your runner, the registration token, which of course you can take from your project. And we just need your GC project name and zone where to create all the virtual machines. I have them all filled up here for the demo. And after that, we have a second command, which is ideally it's going to be it's going to be two commands you can pick from. One is Docker, so you don't have to have any previous dependencies, let's say Google Cloud SDK or Terraform. These are dependencies which we're going to build into the Docker image. Right before the demo, I noticed the Docker image doesn't work. So we're going to go without that. And we're just going to run the script itself. The Docker image does the same basically. We can just run, after we have all the commands, I mean all the environment variables, we can just run up. Now Terraform is going to see if we have any resources existing in GCP. And it's going to go and create everything, networks, virtual machines. And the idea is that these virtual machines are going to be auto-scaling. So you start with one virtual machine and it's going to auto-scale based on CPU usage. So after 10 minutes, you have a ready virtual machine. And while this is creating, it's going to take, I guess, 1 or 2 minutes. I can just show real quick. It's not even that complex. They're just some Terraform stuff. You can configure many of the things you might want to configure, depending on how familiar you are with the runner, or I don't know. You can, for example, change the size of the virtual machine. You can set the auto-scaling parameters also, but everything is pre-configured for you, so it's going to work out of the box. And the whole idea is that each time a new virtual machine is created, when we go inside our runners in the UI, the moment the virtual machine starts up, it's gonna register itself automatically. So we should see one new runner here after the VM is up. And so let's say you start with one runner and you run some jobs and they need to auto-scale the whole, they need to auto-scale to create a new virtual machine. It's gonna start up, register itself. And when the load is down, it's gonna scale down and deregister itself. So it's all automatic. The VM should be created now. It should show up quick, soon, I guess. I hope. How command instances? I don't know. Okay, yeah, here it is. So we have outrunner. This is, I think, the host name of the machine. And this is some prefix. So you can have like 2 or 3 people working on the same GCP project, and they're going to have different prefix for their instances, for example, for different projects. This is mostly to get you started up. It's not advanced, but it's going to work. And then we can just run down, and it's going to scale down everything. And the runner should disappear. And this is a runner running a Docker executor. So you have security by default. You don't need to isolate your environment or anything like that. And after this is downscaled, we are basically done. So if you have any questions, now is the time. Yeah, the runner is gone.
That's awesome. Thanks, Georgi. Question I had, I think I missed this at the beginning. How does someone set this up? Is this a separate project, or is this just a command that you can run?
Yeah, so we basically have a separate project that lives right here. The project itself is going to be renamed to Autorunner.
Okay.
But this is the project, and the project's pipelines built a Docker image. So you're going to get right here on the same place where Jose showed his pop-up with how to install the runner. You're going to have another tab. That's how I think it's going to be. And we're going to give you this Docker command. And it's going to be pre-filled for you. For example, we're going to fill up gitlab.com. We're going to fill up your token. This is going to be missing, I guess, for simplicity. And that's all we're going to have to run.
Okay.
I can show you this part. Just real quick. The way this works is, since you don't need to have Google Cloud SDK or Terraform installed on your computer, it's just going to ask you to go to this link, and it's going to ask you to authorize your Google account. And that's all you gotta do. You need to copy paste this command, authorize, and that's it.
Cool. It seems like it'll be very easy then for people to set up their own runners in GCP.
Yeah, we hope to get to Amazon at some point, but we want to pilot this with GCP for now. It's the easiest for us.
That makes sense. Nice. Any other questions, anyone? All right. If not, we'll move over to Sarah. Looks like you're up next.
Hi, everybody. Welcome to my very favorite day of the month, Demo Day. I have just a little demo today that's more a demo about collaborating and how we're working together on our GraphQL projects. So it's going to be a little bit of code. And that's it. Can you stop sharing your screen, Georgie? It won't let me take over, sadly. Won't give me the power, which I think, frankly, is very rude. But anyway. All right. So first, I'm going to share with you really quick. I'll just share the desktop. If you see any secrets, pretend like you didn't. So first, we're just going to look really fast at what this is. So what I'm working on right now, you guys may be familiar with this really awesome screen. You look at it every day. It is our pipeline graph. And what we're working on is moving the pipeline graph to GraphQL, both for performance reasons and because it's going to let us delete a whole bunch of code that I'm super excited about deleting, the pipelines mediator, our homegrown store, all that kind of stuff, all the homegrown polling. We're going to be able to get rid of all of that and use Apollo. But step one is basically getting all of this data into GraphQL. And Laura has been working really closely with me on it. And there's something really nice about it, which is that we can work in parallel when we move things to GraphQL, which is what I'm going to show. But like, it's really nice because we can just throw together this issue, whereas I figure out which information we need, right? Coming from the REST API, discovering which data we're actually using versus which data we're just pulling down because it's in the API has been a little bit of like a detective adventure. But as I uncover those pieces, I can put them together in this really nice issue and tell Laura what I want. And then she makes the resolvers for me, and it's all really wonderful. And the way that I can sort of keep working while Laura is working on the GraphQL is using our friend, the client directive, which I think you guys can see right here. So this is the query, which looks a lot like the DAG query, which is not surprising because they're all pipelines and the pipeline looks the same. So that's, you know, some confirmation that we're doing this right and using the same data. And I can go through and get the data that I know I have for the DAG already, the jobs, the nodes, etc. And that is coming from GraphQL, which we already have. And then when I know what I need, I use our cool little client directive. And then in the bundle setup, that is the wrong one. This is the right one. In the bundle setup, what I can do is I can write these client-side resolvers for the data that I need. So I can go ahead and add my dummy data. And so the way that works is we create our default client for Apollo. And then just on each GraphQL type, so the pipeline, or the CI job, or the CI stage, the CI group, etc., I am able to just return the data that I want and keep working. And I can show Laura some really nice examples of what I need. And that's been super helpful for working together. Finally, the other big pro of using Apollo is the way its cache works is you can just query Apollo, and if it has the data in its cache, it will give you the cache. And if it doesn't, it will request it for you. But because the library itself is handling that for us, it's been really nice because it also means when I do things like getting the upstream and the downstream pipelines, I can just add my smart query and GraphQL deals with it, which is another probably like 200 lines of code of our own store handling that we're going to get to delete at the end of this. And so that's been a quick demo of sort of how Apollo's functionalities let us collaborate together a little bit more easily. Excellent.
Nice.
No one has any questions. So now Nathan can show us how GraphQL has made it to the releases page, which is probably less of a work in progress.
Cool, thanks, Sarah. Mine are going to be really quick. I'm just going to show two things that we've implemented lately, and I'm not even going to show any code. So this is the releases page, which you may or may not be familiar with. As of maybe 2 weeks ago, this was powered by our REST API, like a lot of our application. But under the surface, if we refresh the page and look at the developer tools, we can see that it is now getting its data from GraphQL. So that's kind of exciting. There's no visual change. It's one of those changes. It was a ton of work, and then the end result was the page looks exactly the same. But that's good. That's what we want. I guess there is one visual change, and this is something to keep in mind if you are implementing GraphQL, is how pagination is handled. So you can see at the bottom here, we have this very simple previous and next pagination control. Our implementation of GraphQL is pretty minimal in what it provides. Oops, I think I just moved that. In terms of pagination info, so all we can do is show if there's a previous page or if there's a next page, and then we just disable them. We don't know where we are in the pages. We don't know how many there are. So it's a kind of a UX trade-off, and I think there's some performance reasons why we do that. So we have some documentation on that if you're interested. So that's the GraphQL update. And secondly, this is not related to CI/CD, but it's something I did and wanted to show off. We now have keyboard shortcuts in our editors, our Markdown editors. So if you, I probably shouldn't be doing this on the live one, but oh well. If you go type something into a Markdown editor and press Command B, we'll get a nice bold text surrounding it. And we also have Command I, which is, oops, that was Command U. Command I, which is italics. Oh, sorry. There we go. And lastly, and the one I use the most often is Command K, which is links, which is kind of handy because it's a pain to type all those brackets. And that's pretty much all I had. I'm really looking at the doc. Oh yeah, okay. So Sean asked, did we notice any performance differences? I think it's slightly slower actually from my testing. So I'd like to look into that more and understand why. Yeah. So I'm hoping that's something we can optimize.
Thanks.
If there's no other questions, I'll pass it off to Etienne.
Yes, thank you, Nathan. Hi, everyone. So I am going to first share my screen. There we go. So for 13.5, I've been working on a new CI template that will allow a user to deploy to AWS EC2. And so I went a bit further this time around because this is an exercise that I did before for ECS. And this time around, I've created a template which I've called CF Provision and Deploy EC2, which in addition to deploying to EC2, also creates a stack. So create a stack on AWS using CloudFormation. So what this exercise revealed is that as we move forward, we're going to have like different way to provision an infrastructure, right? We, as of today, we have the deploy CI template, and we, in that deploy job, we do several things at once, right? We are provisioning on Kubernetes, and then we're deploying the application. But as we move forward, there might be different way to provision and different platform to deploy to. And so I think it's very interesting to have like that modular approach where we have like a provision stage and then a review or a production stage that are like decoupled. So that makes things more modular. And instead of using CloudFormation, we can use later in the future Terraform, right? For example. So that's hopefully what this split is trying to achieve here. So I'm going to show you a demo of that. I used a Jekyll demo sample project. These projects are usually deployed using GitLab pages. So I removed everything that's related to GitLab pages in order to deploy onto EC2. I'm going to open the terminal here and go on to that sample project. And I'm going to show the GitLab CI file. So first I have like a build site job that just build the Jekyll build the Jekyll site, something that the GitLab pages was also doing. And then once that new feature goes out, user will be able to include that template. So that new template, the CF provision and deploy EC2 template. But since it's not, hasn't been merged, I copy pasted the content of the template. So that's the content of the template. I don't have time to go through that. But the interesting thing here is that this template is very like powered by JSON inputs. If I go back here, you can see that there is like a JSON input for each step. And those JSON, for each JSON input has a template that can be found either on the documentation, which will be the case for push to S3, or to the AWS API documentation. For those two steps, you can find templates on the AWS documentation. So I'm just going to take a template here for the create stack step to provision an AWS infrastructure via CloudFormation. So in my example, it's here in the AWS folder, CF create stack JSON. I'm just going to open it. And in here, I create my stack. So I create an EC2 instance, and then I create, what do? I install a few packages, I install Nginx, and I set up an Nginx config file, and then I pull, one second. Yeah, I do just a bunch of things. I did that a couple of weeks ago. I don't remember all details. I create a security group and deployment group, everything that's needed in order to deploy to EC2. And then I push the compile, the build artifact onto S3. And I use also a template, which I fill in order to specify which bucket, S3 bucket, I need to push my compiled project to. And then I create a new deployment. I specify the application name, different attributes related to EC2 deployment, and where the revision to deploy is located to, which is my S3 bucket. A pipeline looks like that. We build first the project, and then we have that provision stage, which provision the entire stack, and pulls once every 10 seconds, checks if the stack has been if the stack has been completed. And once the formation, once the stack is done building, there is just a summary about the stack itself. That's the provision stage. And then we have a review stage here. The review stage pushes to S3, my build artifact, and then deploy to EC2 here. Once again, here, there is a polling that's done once every 10 seconds to see, if the deployment has succeeded or has failed. And then this message comes back here once the deployment is done. If we're looking at AWS to see what all of this looks like, this is the Jekyll demo stack that was built by my provision stage job, and all the resources that are defined by this template, including the EC2 instance demo. And if I look at here, if I go here and open, let's see, how do we? Open the tab, you can see that the GitLab Jekyll template that's my Jekyll demo website. Yes, so that's the template for deploying to AWS EC2 with, as a bonus, the provision job stage. That's basically it for my demo. I'm just gonna check if I have any questions. Yeah, no questions.
Actually, I write it down, but I have a question. As these JSON files need to be provided by user?
Yep.
So for any project, I need to write all of that. Okay. So it's kind of very similar to Terraform, or?
I'm not familiar with Terraform, but here the jobs won't run if no JSON files are provided. There are two ways to provide JSON files, either directly in your project structure, as I've showed you, or as a file type environment variable, which might be a preferred option, right? Because it wouldn't be version controlled. The content of your JSON file wouldn't be version controlled. But you need that content, that JSON content, in order to, one, create your stack, two, to specify your S3 buckets, and then three, to specify your deployment details.
All right, any other questions, anyone? Otherwise, looks like we're back over to Fred.
All right, this one will be very quick. I have two things to show. So this is the pipeline header is this little tool that we have in the pipeline page. Let me bring, where is it? Go. And so in the pipeline page here, the pipeline header is this little widget that we see loading on top here. So this is now in GraphQL. And there were two things that I wanted to show with that. The first one is I have a little video that I made for performance difference with what it used to be and what it is. So I can just play that. You can see lots of animations, pretty cool. And woohoo, what happened? Okay, did it not play correctly? Did everyone see it? Sorry, I didn't even see it.
I saw it for a second and then it disappeared.
Okay, well, it doesn't matter. It's fine.
Like
It's not my day.
I liked it.
So basically, there's a difference of about 2 or 3 seconds per load just for this little widget. And I think that the difference comes from the fact that it used to receive the entire pipeline data, and now we can only ask for a few fields. So this is where GraphQL shines the most. And so the smaller the component, the biggest the load gain. That's what I wanted to show with this. And then the other thing, which is just a very small code thing that I've used. If you ever need to sync your loading state of GraphQL with UI. So for example, in this widget, if we click on like the retry or delete pipeline, then the button itself has a loading, but then GraphQL is also loading in the background. And so one neat trick that I found out is that you can use watch loading as a property in Apollo. And what it will do is that you can say, well, when isLoading is changing, so either from true to false or false to true in this case. So if it was loading and it's no longer loading, so you're done, then also change this button not to be spinning anymore. So you don't have this weird disconnect between your GraphQL and your UI. So they keep in sync, and you can update all of them in this watch loading, which is just a watcher-like view, but in Apollo. And that's it. That's all I had to show.
I didn't get to the document in time, but my question is this in production now, right?
Yeah, it's all rolled out. This is only for the query though. The mutation will come later, because right now it's still using REST for post requests, basically.
Cool, but we're getting them speed increases like now.
Yeah, that this is live now. It's deployed for all project. It was deployed to all project yesterday, so everyone should see it now.
Cool, thanks, Fred.
Congratulations on rolling that all out, Fred. He won't toot his own horn here, but it's been actually a pretty slow rollout since it touches a page that everybody stares at, and he did a really good job doing it piece by piece and monitoring it. So nice work.
Thanks, Sarah. Yeah, it was like a 7-step process.
Nice. All right. Any other questions, anyone? Okay. Well, thanks everyone for the great demos again this month. As always, leave some feedback if you have any in the issue, which is linked at the bottom, last item in the agenda there. And with that, I think we can all go on with our day. Have a good rest of your day, everyone.